Guys, welcome back. We have one more quarter to go. Obviously, I'm gone today, so you do have a sub. Please be respectful and listen. What you need right now on your desk, you need a blank piece of paper, you need a pencil, and you should have a note sheet that was handed to you by the sub. Your transformation project, that will be collected tomorrow. So remember, you had your transformation project. You should end up turning in 4 pieces of paper to me tomorrow. If you forget what it should look like, look at the front of the board. I still have my example up there. All right, moving on. At the top of your blank piece of paper, you need to write MCA question of the day. So, starting today, every day when you come into class, you're going to have an MCA question of the day warm-up problem. In every homework assignment, you will have MCA practice questions. Okay, so at the top of your paper, MCA question of the day. Then once we're done with that, we're going to do our function notes that you have in front of you. And then you have an assignment in Canvas. It's under Unit 13, labeled with today's date. Okay, first question. You do not need to write down the whole question, just show your work. The equation y equals 12x plus 60 can be used to estimate y, the height of a tree in centimeters. That seems pretty important. And x, months after it is planted. A tree is 150 centimeters tall. That's the height. How long ago was the tree planted? So to start this one out, we have this equation that they gave us. Y represents the height. 150 represents the height. So instead of the letter Y, I'm going to replace it with 150. I want to know how long ago was the tree planted. That's what X represents. So now I'm going to solve my equation for X. When we solve equations, I see a plus sign, and I have a multiplication symbol hidden in here. We always undo addition before subtraction, or addition before multiplication. So to undo addition, I'm going to minus 60 on both sides. These cancel out. I am left with just 12x. 150 minus 60 is 90. Next step, I need to get rid of that multiplication sign. So I'm going to divide by 12 on both sides. When I were to type into a calculator 90 divided by 12, I would end up with 7.5. Remember, that represents how long ago was the tree planted. So I look at my 4 options, and I can say 7.5 months. So I should have all of this work shown, and I should have my answer, letter A, 7.5 months, written down on my paper. So that is our first MCA question of the day. You can put this paper into your binder. Make sure that you have it tomorrow. We will do another MCA question of the day. Okay, please have your note sheet out for today. Your linear function note sheet, and have your name written at the top of it. So we have a definition, linear equations. An equation whose graph is a line. It has to be a straight line. That is very important. In order to be a linear equation, the graph will form a straight line. With that being said, each domain, so every x value, excuse me, is paired with one y value. We've talked about that right before break, and now we're talking about it again. So now every domain, every x value has one y value with it, and the graph is a straight line. So I have 4 graphs here, and I would say which of these could be a linear equation. And I would say number 1, even though the lines are straight, it changes direction, it makes a zigzag. That is not a linear equation. Example 2, it is one straight line. That is a linear equation. Example 3, It is a straight line. That means it's a linear equation. Example 4, it curves. That is not a linear equation. Moving on. We are going to fill in these tables again. You have already seen these before. It won't give you your domain. On your paper, it says choose any convenient values for x. We like to have negative numbers, we like to have positive numbers, and we like to keep them small so they're easy to work with. So -1, 0, 1, and 2 are my go-to x values that I want to pick. Next, I'm plugging them into my function, my rule that I got from right up here. So instead of an x value, I'm going to plug in -1 here. Next row, I do 4, I take out the x, I plug in a 0. I'm going to follow that pattern for all 4 rows. Now I am allowed to solve for my y value, my range. 4 times -1 is -4, plus 3, -1. 4 times 0 is 0, plus 3. 4 times 1 is 4, plus 3. 4 times 2 is 8, plus 3. Now I can make my ordered pairs. I need to take my x values and write them first. I need to take my y values and write them second. When you write an ordered pair, you need parentheses around it. So I put -1, -1, 0, 3, 1, 7, 2, 11. If I were to plot these 4 points on a graph, they would form a straight line. We're going to move on to our second example. This equation is different because the y value is not by itself. We are going to change it so that the y value is alone. So just like in our warm-up problem, I want the y value by itself. I see -5x or a -5x, and I say, what is the opposite of the minus sign? It's a plus. So I would add 5x to both sides. Those cancel out. Y is all alone. I cannot do 6 plus 5x and get 11x. The 6 does not have an x attached to it. So I'm going to write this as 5x plus 6. And I just write it next to each other. That is now my function rule. 5x plus 6. Once again, when I pick my domain, I pick convenient x values. I pick a negative number and small positive numbers after that. I'm ready to plug in. Instead of an x value, I put a -1. Instead of my x value, I put a 0. Instead of an x value, I put a 1. Same thing, I'm going to put a 2. Now I can start to solve. 5 times -1 is -5. Plus 6, positive 1. 5 times 0 is 0. Plus 6. 5 times 1 is 5. Plus 6. 5 times 2 is 10. Plus 6. Next, once again, make your ordered pairs. Domain values go first. So I have -1, 0, 1, and 2. Then I'm going to take my y values, and they are going to go second. And I have 1, 6, 11, 16. Those 4 ordered pairs would make a straight line on my graph. Last example, and then you get homework time. This one, they gave me our function rule, x minus 3. So I'm going to plug that in right here. Same thing, pick your easy x values to work with. -1, 0, 1, 2. Instead of an x, I plug in -1. Instead of x, I plug in 0. Instead of x, I plug in 1. Instead of x, I plug in 2. I get to solve. -1 minus 3, -4. 0 minus 3, -3. 1 minus 3, -2. 2 minus 3, -1. Make your ordered pairs. Now that I have ordered pairs, I can plot the points. This is my x-axis, this is my y-axis. X value of -1, y value of -4, my point goes right here. X value of 0, y value of -3, my point goes right here. X value of 1, y value of -2, x value of 2, y value of -1. Now, once I plot the points, I cannot stop there. I must connect my points. I'm going to extend the line. Notice it is a straight line. On either end of my straight line, I must have arrows. In order to get the graph right, it must be connected points that make a straight line with arrows. We have the arrows because the line can go on forever and ever and ever, either direction. And that's what that signifies. In your homework tonight, if your graph does not look like a straight line, something went wrong. You need to fix it. You also need to have the arrows on either end. You have the rest of the time to go into Canvas, go to Unit 13, today's date 4-11, and work on your homework assignment. See you guys tomorrow.